Alrighty, my friends, today we're going to be going over equations, one-step equations to be precise. Prior to this, we went over all of pre-algebra, which is going to be helpful, definitely, in equations, and from everything else from this point forward. So we went over simplifying polynomials, combining like terms, and we went over multiplying polynomials, and we went over dividing polynomials. All that comes into play specifically in the next lesson, right? Today we're just doing one-step equation, so there's not really much of that involved, but it's going to be extremely important that you master what we went over prior to this video. So we're dealing with equations now, which is a lot different than what we did before. Before, again, we chose any of the three stuff we did, the combining like terms, multiplying or dividing polynomials. When we were dealing with polynomials, all we were doing was simplifying. So when we were given a problem like this, we never came up with an actual answer, nor did we ever find out what x was, right? All we did was get the expression that was given and we simplified it a bit. And we made it into 14x cubed. This is not an answer. This is not, well, that is the answer to that, but this is not a whole number. It's not just a number like 5, right? So all we did was simplify for everything that we did prior to today's video. When it comes down to an equations, there's a value for x. You are going to solve actual answer. You're actually going to get a whole number or decimal or fraction, whatever it is, you're actually going to get a number for your actual final answer. So equations, that's how they differ from expressions or polynomials prior to equations. What is an equation? It's pretty straightforward. It says it right there. An equation is a mathematical statement that two expressions are equal. So think of it like this: 2 plus 4 equals 3 plus 3. 2 plus 4, what does it equal? It equals 6. What does 3 plus 3 equal? 6. They are equal to each other. This right here, this is an equation because it's the two values on each side is equal to each other. That's all an equation is. How do you know you're dealing with an equation? Other than doing the problem and then seeing whether you have a value, you come up with a value. It's obviously the equal sign. 3x equals 8. Let's go with 12 instead. We'll actually do this as an example. You know this is an equation because of the equal sign. Equations involve equal sign. That equal sign is actually what gives us a solid answer for x, because that's what equations are. We're trying to solve for the missing variable. We are actually not going to come out with a simplified version of this expression. No, we are going to come up with the answer for x. That's what equations are meant to do. So we must master first, before we get into the complicated multi-step equations, we have to first master our one-step equations, and that's what today's lesson is. If I were to write a one-step equation here, such as 3 plus x equals 8, you can probably look at this and determine what x is just by looking at it, right? Just ask yourself, 3 plus what number gives me 8? And then you probably think for a sec or two, and then you could guess the answer, right? You use your fingers and you're just like, oh, let's see, 3, 1, 2, 3, 4, 5. Oh, 5. 5 is the answer. X equals 5. You could guess and check with one-step equations. So the whole worksheet that's going to come after this, you could probably guess and check, right? But that is not the purpose of today's lesson. It's just to try to guess what the value for the variable is, the letter. We are going to determine the answer using one-step equations, using using math pretty much. How do we solve this problem mathematically? This is the step-by-step guide right here. Always, wherever you see the equal sign, always make your split. Okay, from this point forward, I want you to think of this little split as a wall, okay, and it separates two sides. And what we are trying to do is, in our one-step equation worksheet, in our one-step equation lesson, is move letters to one side if needed, or numbers to one side if needed. Pretty much the wall is separating numbers from letters, okay? They don't like each other, so we want to separate it, because right now there's war happening and we want peace. How's this going to be peace? By separating the numbers from the letters, right? Where's the war happening right now? What side is kind of mad? Well, on this side, side A, if you want to think of this as, there's a number and a letter next to each other. And on side B, there's a lonely little number, right? So we can determine what we need to fix. We need to determine what's the one thing you need to move so that the letter is happy or the numbers are happy. What needs to be moved? Don't worry about how to move it just yet. Just determine if you needed to move something from one side of the line to the other side of the line, what would it be? Would you move the X from this side, side A, over to side B? Is that what you want to do? No, because all you're doing is moving a letter here. Let's actually do this fancy technique. All you're doing is literally getting the X, the letter, and moving it over there to the side B. And what do you get? We get a letter still next to a number. And remember, they hate each other. So that can't be it. Do we move the 8 over to the other side? Wherever? I don't know where you would put it, right? We're not determining exactly how, or I haven't explained yet what you do on the how do you move it yet, but overall, if you did move the 8 over there, no matter how you would do it, would the worlds be happy? No, because the letter is still now double ganged by numbers. So that can't be it. What's your last option? Moving the 3 over there. If we move the 3 over to the opposite side, that would make the worlds happy, right? This side would have letters and that side would have numbers, and everyone's peaceful. So you've just determined what needs to move. And that's the most important part of today's lesson, is determining what needs to be moved. The second thing you have to ask yourself is, how do you move it? And that's where 4 differential ways comes into play. There's 4 different ways to move something. It depends on how the equation is presented. In this specific equation, the 3 needs to move over there. How do you move the 3? Simple. The opposite of the sign. This is a 3, right? What's the sign of the 3? Is it a positive or negative 3? Well, look to the left. What number do we see, or what symbol do we see? We don't see a symbol, but that just means that that if you don't see a number or you don't see a symbol, it's a positive, right? So if we know this is a positive 3, I know the opposite would be a minus 3. You always do the opposite of the number or the opposite of the sign, because sometimes we have to move the letter, right? That comes later. But we just have to do the opposite of the symbol, because that's what cancels this out, and then it throws it over to the other side. Whatever you do here, you throw it underneath its like term, the other number, right? And then that's what get us our, if we did this operation, 8 minus 3, what do we end up getting? We end up getting our answer 5. All right, you are always doing the opposite of the sign. So if we look at our next example, such as this one right here, let's go with x minus 6 equal, actually, let's switch it up a bit so y'all could get familiar. Okay, 3 equals x minus 6. Always determine what needs to be moved first. That's what we're always trying to do, remember? And remember, if it helps, always write through your little wall, right? Look at it and determine what needs to be moved so that there's no more hatred going on, no more fighting. Well, if you look closely, the negative 6 needs to be moved, right? That 6 needs to be moved. How do you move that 6? Opposite of the sign. This 6 right here, what is its sign? It is a -6. So u plus 6. That's what cancels it out, vanishes from here, and it gets deported to the other side. Plus 6 with symbol and all. Okay, that symbol that you do is actually key because that's what's telling us what operation to do on this side. 3 plus 6, what do we end up getting? We end up getting 9 equals x. Some students always ask me, why does it go underneath? It's because it has to go underneath its like term. Whatever it is you're moving from one side of the equation, or from one side of the line to the other, it always, whatever that thing is that you're moving, it must go underneath its like term. You already know what like terms are. So if you don't, go look at the simplifying polynomial video a couple lessons back. But if this is a 6 that we're moving, it must go under its like term on that other side. Well, this one's easy because there's nothing else on this other side. On side A, there is nothing else. All I see is a 3, right? Which happens to be its like term. Numbers and numbers are like terms, so it went underneath it, right? In the next lesson, multi-step equations, there's going to be a lot of stuff on each side, a lot more stuff, and it's going to be a little bit more confusing. But let's just practice in today's lesson the skills of moving stuff from one side of the equal sign to the other. This is what today's lesson is, one-step equations. It helps us with the movement of equations, and it gets our brain going with math related techniques. Again, because I do not want you just to look at this and be like 9 minus 6 equals 3. Yep, that's the answer. Do not guess and check. So this first example was an example of how when you subtract. The next example based off of the sign was an example of addition when you add. Still sticking with these two examples, there's something you need to be aware of, such as this problem right here. -12. Throwing negatives everywhere now, right? Making it a little bit more challenging for y'all. So, what is the steps you need to do? Make your line and determine what needs to be moved. Well, hopefully you've developed that skill now, and you notice that the 3 needs to be moved. How do you move the 3? Opposite of the sign, right? So in this case, -3, -3, same thing. And you throw it over there, and we end up getting -12 minus 3 equals my -15. And remember, always pull up the calculator. Please download the calculator from the video from the first module, how to download the GD calculator. So you could get a digital version like this. But you would do -12 minus 3 to get my -15. Just always assure that you got the correct answer. But we are not done in this specific example, because the rule that you must always take from this is you are never done unless your variable, the variable that you're looking for, in this case x, is positive. In this case, there's a negative x, right? Specifically a -1x, because there's always a little invisible 1 there. Am I correct? So you are never done if your variable has a negative. What do we do in this case? In this specific case, you guys got to learn the next thing I got to show you a bit, right? Which is this right here. We're going to come back to this. So put a little comeback on that. Let me remember. You have to know that this is one way. These were 2 ways of moving stuff from one side to the other. You either add or subtract depending on the symbol of the number, right? But what happens when a number is attached with the variable? You get this right here. So if you looked here in this first example, the letter and the variable and the number are separated via an operation sign. Same thing with this one here, via an operation sign. The letter was separate from the number. In this case, if you look here, they're really butted up against each other. They're together, right? They are smooching. They are kissing each other. The 4 and the x. What does that imply? That means multiplication. I did say this in a couple of videos back. Whenever you see a number and a letter next to each other, all it means, even though you don't see it, there's parentheses there. It's 4 times x. So what do we need to do? Same thing as before. Always make your split if it helps. Make it in a different color. Split. What needs to be moved? Well, hopefully now you using your skills, you know the 4 needs to be moved, because remember, numbers hate letters, and you want one side dedicated to numbers, one side dedicated to letters. So you know the 4 needs to be moved, but in this specific case, when you see them smooching each other, when you see the number and the letter butted up against each other, you can't do the opposite of the sign. This was a positive 4, I'm going to do a minus 4. No. This, not in this case. In this case, you do the opposite of the sign, but not the sign of whether positive or negative. It's the opposite of the operation. In this case, it's 4 times x, right? 4 times x. What's the opposite of timesing, of multiplying? It's dividing. You will divide by the same number in these cases. You divide by the same number, not the opposite. Don't divide by negative 4. No. You just, whatever the number is that you want to move that's attached with the x, in order to detach them, you divide by the exact same number. 4 divided by 4 cancels that out, and again, just like before, it gets thrown over to the other side in the same format. So in this case, 12 divided by 4 is what you'll be doing. X equals whatever the answer is from this operation, which is 3. So when you see numbers butted up with letters, you have to divide in that case. So if we go back to the example we were doing on this side, I already told you there's technically a little invisible 1 there, so it's negative 1x. This is why you're not done in this specific example. If I want my x to be positive, how do I do that? Well, if you know this is a negative 1x, you see a negative 1, you see the letter, they're butted up with each other. You need to divide by the negative 1 to cancel it out, making it an invisible positive 1, aka just the x by itself. And that one gets thrown over there, giving you negative 15 divided by negative 1. What's the answer? Positive 15. And again, always use the calculator in case these negative operations are a little tough. But yeah, so there's 2 things I showed you. It's when you use division to move something from the opposite side, and that's when the number and the letter are butted up with each other, and how your answer is never done unless your variable is a positive. Okay, all our examples, it must end as a positive. That's when you use division. There is one more you need to learn, is when you use multiplication to move something from the opposite side. When would that be used? You use that when we are dealing with this. Okay, here, this one's a lot more visibly obvious. This is a fraction, right? You have a number divided by 4 should give you 3. Again, you could guess and check, but I don't want you to. I want you to use the math. So this one is the toughest one of them all, because if we were to split and we were to ask yourself what needs to move where, in this specific case, you would tell yourself the 4 needs to be moved in order for the worlds to be happy. That's what Neil said. Always look for the one thing that needs to move so that the worlds are happy. And in this case, 4, it would be that case. But when it comes down to these problems, you're not really asking yourself that. All you ever have to know when you're dealing with a fraction like this, with an equation with a fraction, is wherever your fraction is, the denominator, aka the bottom number, you will always get that and move it to the opposite side. The denominator. Alright? How do you move it? Via multiplication. This is what I mean. You will get the bottom number, or the bottom term. You will cancel it out and throw it over there via multiplication. Either times 4, or you could write it like this. Right? And that would give you your answer in this specific case. 3 times 4 gives you my 12, right? But it's always the denominator. Why is that important to know? Always the denominator is because of more problematic questions like this. 12 divided by x equals 4. Here, if you were to split here and ask yourself what needs to be moved, you would essentially move the 12, but like I said, that's not correct. You can't use that logic in these examples. The logic here is always move the bottom term. So if we were to get this x, which happens to not be a number, it's just an x, and we move it over there, we're really contradicting ourselves, right? We're just like, wait, we're moving a letter over to another number, and they're not happy. You're right. But it's what's needed in this specific example, because the next step that comes after that, this is an example of a two-step equation. The example that comes after that solves the issue. So if we get the denominator, we move it over there, what we end up getting is 12 equals 4x, right? You could write in parentheses, it doesn't matter, because 4x means 4 times x. And then here we look at it and we're just like, so we didn't solve for x, and there's still war happening. Nobody's happy. What the heck? What was the point of that? The point of that was because now we use the skills that we learned in the previous example of multiplying, or dividing, I should say. So if we go over here, you should be able to know what to do next, right? Here you could say, oh, I know this one. Here I divide by 4 and I get 3 equals my x. This is an example of two-step equations, right? When the variable, when the denominator happens to be a variable. So these were one-step equations. It's actually pretty tough, which is why there's so much in the worksheets, so much examples for, and so much of different kinds. There's all 4 kinds. There's the, obviously, just making stuff up. This one you're going to have to minus the 3. In this next example, you're going to have to add the 6, right? And then we have 7x equals 14. Here you're going to divide, and then obviously there's 2 types of fraction problems. When you have a denominator below, or if you have a number below, which is the easier one of the 3. These are your 4 examples that you're going to come across in the worksheet, and you have to use your skills of, for these 3, determining what's the one thing that needs to move and then moving it, and then for these 2 types of example is just always moving the denominator to the opposite side. These are one-step equations. Please master this. I have a saying that says, if you master equations, you've mastered the test. This is why I made this video so long. Please try to look at it over and do the worksheets and ask for help. See ya.